Today we're going to look at comparing two distributions. So we've been looking at histograms and box plots in order to look at a single distribution. But one of the things that we often want to do is look at two different distributions and be able to make comparisons. So in this example, Josh is just starting a round of golf. His first hole is 130 yards long. He needs to decide which club to use for his first shot. He's kept careful records about how close his first shots come to the hole, all from this same distance. His records include data from his use of two different golf clubs, a wedge and an 8-iron, over the past year. So with a wedge, he gives the distance to the hole in yards. Notice on one of those, what happened on this one?
It didn't move. He missed.
No, this is the distance to the hole.
He made it.
Yeah, it's enough. It's either close enough to where it's a tap in or something, but if you're doing it in yards, and he didn't give any decimal places here, so that's definitely less than a yard, probably less than half a yard. So he's maybe a foot away or something. Okay?
Hole in one.
Could be a hole in one also. Okay? And we have all these other ones. And then with an 8-iron, he's used that more often and he's gotten the distance to the hole. All right. So the mean and the median, let's see if we have some agreement on this. So for the wedge, who's got the mean for us? 8.3?
8.3 repeating.
8.3 repeating. Do we have any agreement on that? Why are people looking it around? Look at your paper. Do you have 8.3 repeating for the mean? Yes or no? Let's do a show of hands. Wow, there are a lot of people looking around doing weird faces. How many of you have 8.3 repeating for the mean for the wedge? Okay. Johnny, what do you have? 8.2. Paul, what do you have? Okay. Cooper, what do you have? For the mean for the wedge. It's the first thing they ask you to do. Christian, 8.2? 8.2? Pardon? 8.2?
8.2, but I'm doubting myself.
Okay, well, I'm going to assume since almost everyone got 8.2 that there was a small problem with yours. What about the median? 4? Do I have some agreement on that? Yes? Yeah? Okay, so that's for the wedge. And then for the 8-iron, what's the mean for that? No one wants to share now. They're all afraid they're going to be wrong. It's okay if you're wrong. It's not a big deal. Johnny, what do you got?
I got about 9.71.
About 9.71? Do I have anyone who agrees with that? Wow. Nobody agrees with that. Somebody else have a different answer to offer? Yes. 10.6. Anyone agree with 10.6? Wow. What do you have, Christian?
I got 14, 9/14.
You got what now?
What?
Just say it again.
14 and then 9/14.
Oh, 14 and 9/14. Anyone? Anyone? All right. I'm going to grab my calculator and do it real fast. So this is for the 8-iron. How many of them are there?
14.
There's 14?
Very.
So I got about 10.4. I just counted it. I got about 10.4.
So when I added them together, I got 149.
Yeah.
Bro,
But I got like 10. I haven't even finished it yet. I just have 10.4 right now.
So did you say you had 10 and 9/14ths?
no, I said 14 and 9.
I mean, you have 14 and 9? No, it's 10 and 9/14ths, not 14 and 9/14ths. Yeah, it's 10 and 9/14ths, or 10.6 approximately.
So I got it right.
Sammy, you were talking
You got it
about
right by
Y'all
mess-
were all.
You got it right by messing it up.
What? When? You did bag over something. When?
All right, how about the median for that one?
10.5.
I heard two 10.5s. Anyone disagree with 10.5? What did you get? All right. Well, fortunately, I've drawn the histogram and box plot for this. And the box plot clearly shows that it's not 10.
This kid.
I think 10 and a half is probably correct. All right. So here are the box plots and the histograms. So let's take a look at those. There's a couple of things you should notice. First of all, the box plot for the wedge is more spread out, isn't it? There's a greater spread in our data. And notice that the inner quartile is way more spread out than this one is. But notice there's this gap here. He either does pretty well with his shot or not very well. With this one, it's single peaked. He's very consistent in that he hits somewhere in here most of the time. Occasionally he has some bad shots, but only very rarely does he have a good shot, a really good shot. All right, so to find the typical distance that Josh hits the ball from the hole with a wedge, is the mean or the median a better choice? Why?
Because the outliers can go.
There's no. Do we know we have any outliers?
Oh wait, no.
But is this skewed this direction? Yeah, a skew to the right will also artificially pull up the mean. So the median. The median is the better choice. So with a wedge, the typical distance is what?
5.
Pardon?
0 to 5.
No, the typical distance. It's about 4. When we say the typical distance, we're not looking for a range of values. And then for the 8-iron, did it really matter which one of these we use? No, because this is not real skewed to one side. It's fairly what we call normal looking. So for the 8-iron, we'll say 10.5. Now, which club do you think he should use?
The wedge?
Which club do you think he should use? Remembering that close to the hole is better.
The wedge?
Why?
Because he hits closer.
He tends to hit closer to the hole. Yep. Why would an 8-iron possibly be a good choice? What is it about the 8-iron that makes it good?
He's really consistent.
He's more consistent. Okay? So it depends. With the wedge, he's more likely to get closer to the hole, but with an 8-iron, he's more consistent. So it depends on what you want, right? If you really need to win this hole, then you probably want to get as close as possible. But if you're looking for consistency, the 8-iron is your better bet. So our answer is, it depends. The wedge typically gets him closer to the hole. But he's more consistent with the 8-iron. And before we go on to the back, I'm going to look at one thing. What about this data gives you an idea as to why he might be more consistent with the 8-iron?
A lot of the numbers are in the double digits.
Nope.
The numbers are the same.
No,
There's more numbers?
there's more numbers. It looks like he uses the wedge more often. If he uses the wedge more often, he probably has gotten more consistent over time with it.
Eight iron.
The wedge?
I'm sorry, with the 8-iron, right? He's shot the 8-iron more often, so that's maybe why he's more consistent. All right, let's move on. So it's just as important to consider the spread of the data as it is to consider the center when comparing data sets. So let's find the interquartile range for each of these. So to do that, we need to figure out what is quartile 1 and quartile 3 for each. Hopefully, since you've already put those in order, it will not take long. Everybody find quartile 1 and quartile 3 for both of these. Check with somebody nearby you. When you have found them. And if you disagree with one another, have a discussion about it.
I'm talking about the 8-iron. For the 8-iron, I got 7.5. Still, yeah. IQR for wedge.
All right. Anybody need any more time for finding those? Okay. So for the wedge, quartile 1. Anybody? Yeah.
Oh wait, quartile 1
It's what?
is 2.
2? Anyone disagree with that? All right. What's quartile 3? Somebody else volunteer for us. How much? 15? So the interquartile range will be 15 minus 2, which is 13. 13 yards is a long way. All right, what about for the 8-iron? Quartile 1 is what? 8, and quartile 3? 12. Any disagreement with that? So the interquartile range is 12 minus 8, which is 4. So if Josh decided to use the 8 iron, and this is, Ben, this is what you were talking about, he could typically expect to hit the ball so that it lands between 8 and 12 yards from the hole, right? We wanted, the other one, what is the typical, this is a range of typical values. That's indicated by the box on the box plot display and corresponds with the IQR. If Josh decided to use the wedge, the typical interval of distances from the hole he could expect the ball to land would be from 2 to 15 yards from the hole. And we've actually kind of already answered part C. If we look at the intervals, do you want to modify the advice? Well, the advice we said is it depends. Do you want to be consistent, or do you want to get really close to the hole? And it may depend on the size of the green. Let's say the green is small, right? The green, that's what you try to hit the ball onto. It's the part around the hole where the grass is cut really low, and you typically putt from there, rather like you do in putt-putt golf, rather than, having to use a wedge or a driver or something like that. That would be interesting. But if it's a really big green, and it's really flat and easy to read, then maybe you're like, I know I'm going to get on this with my 8 iron. Maybe you'd want to use that. All right, so Mr. Webb has only one more starting position available on his basketball team, but 2 students have tried out for it. He wants to choose the student who is likely to score the most points. The students from whom he can choose are described below. In her most recent games, Jana scored 7, 46, 9, 6, 11, 7, 9, 11, 19, 7.
No. How do you score 55 and then score 7?
On the other hand, Alejandra scored 13, 15, 9, 8, 13, 17, 17, 15.
He's better.
Girl.
It's a girl.
All right. Alejandro would be a boy. Alejandra is a girl.
Yeah, Cooper.
She's better than Janet.
All right. So, which girl do you think is going to have the higher average?
She is the most outlier, so it's gonna affect the data.
Yeah. So when you have an outlier like that, she actually has 2. That's likely to really pull up her average.
But still, Alejandra is better.
So I'm pretty sure, even without doing it, that Jana has the higher average. All right, let's make parallel box plots for these. I'll give you a couple of minutes. You're going to need to put your data in order, find the quartiles and the whole deal.
Does parallel be like that?
Parallel means like this.
What was 7?
It can't be like that. Nah, bro, if I go from 46 to 9, it's not even right, so.
What do you think the length of the box
Trash.
the line underneath the
I'm better than
width
Oh, like,
between each?
well, what's the highest and what's the lowest? So the absolute highest is 55, right? And the lowest is 6. So if we do it by fives, is that going to be enough? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. Going by fives will work.
Paul, can you please be quiet?
And then let's do the around here. You don't know what it's doing like that thing.
So I've only did one so far.
That's fine.
You brought it yet? We don't have the average done yet. We don't have to average it. That's not what we're doing. We're making box plots right now. Yes. Averaging it.
She has 16 games.
Johnny, do you have both box plots drawn?
Yeah.
Okay.
There's no outliers.
Jana played 16 games.
No outliers.
What'd you get for Q1 and Q3?
Because I need to know if she played 16 games or not.
What do you
Then
got?
count.
I did, but last time I counted, I got it wrong.
So count
You didn't pass first grade.
guys.
Bro, Alejandra is so much better.
Bro, that's so much better. Why not? Alejandra kind of scores.
Jana is
No, I think Jana kind of scores like.
I love that one long with skirt.
You love that one long. I said Jana kind of scores like me. Actually, Alejandra kind of scores like me.
No.
I usually score about that much. No, Alejandra.
That doesn't mean she's better.
It does.
No, it doesn't.
She had a 55.8.
Okay, but Alejandra is consistent.
Yeah, but
Stevie Curry.
yeah, but
Yes, he could. He did it before.
What about
He did it before.
I don't even know. It's like we just end up with points somehow.
James Brown?
That means Where's the only time the biggest sports player
I can't even think of people.
What about Shai Gilgeous?
Shea Gilgeous.
SGA?
How do you know who that is? Shea.
Shy Gilgis.
How does he know who Shea
How
is?
do you know?
OKC.
Kid.
How does he know who Shea is?
I don't know.
Thunder. Victor Wembanyama.
It's blocked by a woman, yeah.
Ain't no way. You know the third string center for the Houston Astros?
Wait, Dunk.
But what?
The third string center?
For the Houston Astros.
I do.
The third string center?
Wait a minute.
I
There's-
think it's.
I don't think there are any centers on the Astros.
I'm pretty sure it's. Wait, hold on. Let me guess. I think it's. Let's see here. It's.
All right.
Hold on. Let me guess.
All right. Enough guessing.
Some hockey player.
All right.
You've been roasted.
So let's see if you got these. I got that for Jana, the minimum was 6, and that the first quartile was 7.
Yup.
The median was 9. The third quartile was 19. And then the maximum was, of course, 77. 77? That's not right. What was it? 55. I accidentally typed in the wrong number. But I don't think it affected anything. So, your box plot for Jana looks something like this. Thank you. All right, and then for Alejandra, let's see, the minimum was 9, right? Quartile 1 was 13. Yes? No? Maybe? 13?
Yeah.
And then the median was 15. And quartile 3 was 17. So, should look something like this. And what was this number? Was this 18 or 19? 19, thank you. And this was 17. All right, why is the mean not a good measure of Jenna's typical performance?
Outliers.
Yeah,
Steve, please stop talking. I'm trying to watch this.
so Jana's scores have some high outliers. That increase her mean. In fact, according to my calculator, and we'll talk about this another day, we aren't going to do it as of yet, but it actually says that 55 is an outlier, and so is 46. That both of those are outliers to this. Okay, so it says there's actually 2 outliers. Now, let's find the IQR for each girl. So for Jana, the IQR is 13. All right, y'all have a good day.